I hope everyone is in good condition. And how was your contest? Is the contest easy or hard? Or which problem is the easiest and which problem is the hardest? Okay. All right. So before we start our discussion, let's begin with praying together. Allahumma inna nas'aluka ilman nafi'an wa rizqan thayyiban wa amalan mutaqabbala. Rabbana zidna ilma warzuqna fahma. Amin. All right. So before we discuss the solution, so can you mention your final score? So how many points you got? Is there any connectivity issue? Okay. All right. Yes. Yes, please. All right. Yes. Okay. So are you ready now? Okay. Then let's start our class. Okay. So let's wait for him. Okay, interesting.
So, uh, in the problem statement, it was mentioned that uh, s plus 2 power k will not exceed the length of the string, but in the test cases it was exceeding. So my code was getting runtime error. But when I resubmitted that, I got 50. But GJ was having the same error, and when GJ resubmitted his submission, then he got 13. But I don't know why he's saying that he got 50.
Right. So it means the test case is incorrect. So it is not your fault. Okay, but if it is not your fault and it is the 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 author's fault, so we can it is understandable. So we can consider them. Okay. All right. The example is wrong. Right. Okay. For this, it is correct, correct, correct. How about this? 0, 1, 2, 3, 4, 5, 6, 7. Wait. 0, 2. Okay, yes, it should be true. All right, let's discuss further when we are discussing the second problem. Or maybe let's start discussing from the second problem before the others. Okay. Okay, so welcome Ahmed. Can you mention your score, your final score? All right. Okay, so let's discuss from the uh, most curious problem, the second one. All right. Okay, so this is the most suspicious problem. Maybe because of the test cases, we can also incorrect. So is there any other comments about this problem? Okay, so the concern is at first 2 to the power of k sometimes greater than n, right? It means it is wrong. And the test case is weak. It means some solution passes the test cases. All right, unintended solution. What else? Okay, all right. Anyone got accepted on this problem? No. All right. Okay. All right. Let's see. So who don't realize this? So get runtime error. Maybe Saram and DJ, right? Yes. Okay. So Anik didn't have any problem with this, did you? All right. Okay. All right. So on contest, you got runtime error because of this, and then after contest, you resolve this one and got more points. Is it correct? Okay. But for Anik, you realize this on contest, didn't you? All right. So Anik on contest and the others after contest. And then, isn't there any unintended solution? The solution that should not got accepted, but sorry, should not got the second subtask, but you got. Is there any? Yes. Ooh. Okay. All of you? I mean, three of you? All right. All right. So Chiche has the correct solution. Is it correct? All right. So using the same brute force idea, uh, Saram and Anik got 50, but Chiche not. And you got that after contest. All right. Okay. Wait. Well, wait. Saram solved it on 12:30, right? So when you start the contest? When did you start the contest? Okay. All right. Never mind. So it is okay. If you got 50 point, then that is your score. Because in IOI, if there is a weak test case, you still uh, you still got that point. All right. No problem. Okay. So do you have any idea for the second subtask? Anyone got the idea? Okay. I think Chiche got some idea. Okay. All right. So the point is all of you write the brute force solution and pass the second subtask, right? Wait 3 seconds. And this is, I don't know why this passed. Maybe the test case is weak. Okay, so DJ has an idea using sparse table, right? Okay. Yes, that's the final solution. The final solution using sparse table. And okay, for the first subtask, it is easy, right? Because we can solve it in ONQ. Because we can just, for each query, we can just try to shuffle them and just check whether the string are same or not. Okay. And how about this one? Okay. How about the third subtask? This randomly chosen. Maybe wait. If it is randomly chosen, it means the test case is weak, right? All right. Actually, for this, it is using hashing, right? We can use hash for binary number, and since the value are random, so we can avoid the collision easily, right? Okay, that you got the second subtask, and there is no random constraint here. Wait, is there any statement that say that 2 to the power of k always less than or equal to n? Which one? It is current in that sequence. All right. Okay. Yes. So it means 2 to the k should not greater than n. All right. So it means it is wrong. Yes. I mean I plus 2 to the k should not greater or equal to n. Wait, equal is still correct. Should not greater than n. All right. So how to solve this? We can use TJ's idea using something like sparse table. How to do that? Actually, when we are solving a sequence and the length is 2 to the k, we can split into 2 and the size is 2 to the k minus 1 each. And then, you know, for each number here, wait. Uh, for each number, for example, the binary representation is like this. Sorry, it is palindrome. If the binary representation is like this, then we will swap this, right? Become like this. We will reverse this. All right. So let's say we have reversed them. Reverse this part and this part. We have reversed something like that, and we have reversed here. Then how about the combined array? So for this case, it means we ignore the most significant bits, right? Because the bit is fewer, less than this. And also for this it is the index start with 1, and we are ignoring this, right? Okay. Yes, that's correct. So if we are only considering k minus 1 bits, something like this, then for this part, it will go to even number. For this, it goes to odd number. So it means for the result of this to half, so we will match them into even index. Is it correct? And for this one, it is for the odd index. Okay, is it correct? All right. Then again, we can use hashing. So let's say we do hashing with base p, right? The base is p. If we have if we want to find the hash for this and the base is p, it is base in base p. So we need to find the hash value for this, but the base is p square. Is it correct? How do you think? So if the base is p square, it means it is multiplied by 0, multiplied by p square, multiplied by p to the 4, p to the 8, sorry, p to the 6, p to the 8, and so on. And also for this 0, p square, p to the 4, p to the 6, and so on. So it means this is p to, this is 1, p to the 0, right? And this is p to the 2, p square, p to the 4, and so on. And then let's multiply this value with p. So it became p to the p only, and this is p cubed, p to the 5, p to the 7, and so on. So it means it came to this value. All right. Okay. So it means, okay, this is the solution for subtask 2 before we discuss about the full solution. Yes. Okay. Yeah. And all right. Let's say we have a sparse table starting at 1 and the size is to the j, and then the base is, if k is equal to 0, it means the base is p. All right. Okay. Then how to solve this? We can just use this sparse table I j minus 1 like this, j minus 1, and then it is I plus 2 to the j minus 1 is 2 to the j minus 1. The base for this is p, for example, and the base for this is p square, right? So it means it is k plus 1 added by p times sti plus 2 to the j minus 1 j minus 1, k plus 1. So it means if k equal to 1, the base is b squared, right? B is any number greater than 26. Maybe you can make it 29 or 31. Okay. And for k equal to 2, the base is b to the 4. K equal to 3, it is b to the 8. Is it understood? So it is b to the 2 to the k. Okay. So what is the complexity for this? The complexity is, of course, we need to pre-compute or pre-calculate ST. Yes, that's correct. There are n and there are log n. Wait, what happened when 2k greater than n? Do you know? Is it always false? So how you handle this? False. All right. Okay, maybe that's why only few people solve this because of the wrong test cases. Because it should be easier. Maybe it should be easier than this, but I don't know why only 32. It is the smallest among the others. Maybe because of the incorrect test cases. All right. Wait, so it is log n and it is also log n. Okay. So it is log square n. And for n is up to 10 to the 5, it is still past the time limit. Alright. Because it is around 4 to the 7, right? 4e7, I mean. Okay. But how about the full solution? Alright. So the dimension of the sparse table is like this. Sparse table IJK is when we okay. So the main idea is we want to find the hash for the original array and find the hash for resulting array, right? If the hashes are same, it means it is true. Otherwise, it is false. And how to find the hash for original array? It is easier. Hash of original array. We can just do this. And the base is b, for example. Ori ij is equal to Ori ij minus 1 plus Ori I plus 2 to the j minus 1, j minus 1 times b to the 2 times j minus 1. Is it correct? Okay. Okay. So let's pre-compute fx. For example, fx is b to the 2 to the x. We can easily do this. F0 is equal to p and fx is equal to fx minus 1 square. Is it correct? So we can easily know the value of this. I mean, this is equal to fj minus 1. All right. And of course, for Ori I0, it is equal to the character I AI. All right. Is there any question about this first table? All right. Then let's think about how to create a hash for the subarray after reordering. So let's create a sparse table ijk. It means starting from I and the size is 2 to the j, just like Ori. Then what is k? K means the base of the hash is equal to fk. Alright. What is the base? So actually our hash function is like this. The first value times the second value times base times the next value times base square and so on. Is it understood? All right. And the base is fk. It means like this. It means if you want to check whether the solution is true or not, just check whether REIK is equal to STIK0 or not. Is it correct? Okay. So are we using base equal to P? So if it is 0, so it means the base is equal to P, right? P to the 2 to the 0, it means P to the 1 equal to P. All right. Okay. Then how to find the solution for STIKJ? The idea is like this. Let's split the array into 2. As usual, just like the idea for our sparse table. And for example, we have reordered them. And we want to find the reorder of this. For example, we want to find the the base is equal to P to the P to the 2 times K, right? So we need to know the reorder of this, but the base is P to the 2 to the K minus 1. Okay. Wait, sorry. K plus 1, not K minus 1. How do you think? Plus 1 or minus 1? Okay. And for its number here, plus 1, right? Yes. For each bits, for example, the index of this is 0, 1, 1, 0, 1, 1, 0, 0, 1, for example. So when we reverse this, the value is equal to this, right? Let's say there are k bits here. And if it is only k minus 1 bit, this value become this, right? But sorry, I mean j bits. If it is only j minus 1 bit, if we reverse them, become like this. But since there is another bit, so it means it is just like multiply by 2. So it means if 0 becomes 0 here, it is multiplied by 2. If some value, maybe 2 become 1, so it is multiplied by 2. This multiplied by 2. It always came to the even number, right? Okay. And how about this? So in this case, in the second one, the first bit is 1. So if we only care about, say, -1 bits, it is like this. But if there are more bits and the most significant bit is 1, so the least significant bit become 1 here. So it means from this, it came to odd number. All right. Okay. So if we see the contribution value of the hashing, the contribution value here is b to the 0, of course. After that, b to the 2k plus 1. 2k plus 1 means b to the k plus 1 times 2. Wait. Is it correct? Yes. It is just like, sorry. B times 2 to the k plus 1. It is equal to b to the 2 times 2 to the k. It is equal to b to the k square. Right? Okay. And it is the best for this. It is the best for this. Let's say it is C. The best for this is b to the 2k like this. So it means the best for this is C square, right? So it means it is C to the 0, C to the 2, C to the 4, C to the 6, C to the 8, and also for this. Okay. Then if you want to combine them, okay, the value is still same. But now since the base is like this, so it came to C to the 0, C to the 2, C to the 4, C to the 6, C to the 8. And for this, just multiply it by C. So it becomes C to the 1, C to the 2, C to the 4, and C to the 5, and so on. Okay, finally, the formula is like this. Sparse table for I, j, k is equal to sparse table for I, j minus 1, k plus 1. It is like this. Plus b to the, fk, right? Fk is b to the 2 to the k. So fk times this. Stij minus 1 k plus 1. I plus 2 to the j minus 1. All right. Okay. Yes, this is the solution for subtask 2. Is it understood? Maybe if the test cases are weak, it can pass for the full solution. If you solve n square and it pass second subtask, so hopefully if you solve this, it can pass the last subtask. All right. Okay. Maybe. But and this is 5e5, right? So the log factor is around 20. How about multiplying with this? 2e8. Yes, maybe it still can pass, but we don't know. But actually, there is another solution, faster solution. The complexity is only n log n. N log n plus q, of course. And our previous idea is n log square n time plus q. Yes, because wait. Yes, maybe if your code is good, it is only for only triple loop, right? Only triple loop, and we are only adding and multiplying with f. we can pre-compute f, maybe it can pass. Wait, but there is a modulo, but I think it is okay. Wait, memory. Okay, how about the memory? Is there any problem with the memory? You can use flying table actually, if there is an issue with memory, because you know, at last we only need k equal to 0. Sorry, yes, we only need sparse table ij0, right? Okay, and for I log n0, I mean, okay, for ij0, we only need ij minus 1, 1, right? So we only need j minus 1, 1. For j0, we only need j minus 1, 1. And then we need j minus 2, 2, j minus 3, 3. Okay. So just do this. We need only n log n memory. And after that, just erase them. Just reuse them for another variable. All right. And then just continue finding the next j and so on. So we just need n log n. All right. Wait. I missed something. Okay. There is a modulo operation here. Do you know how to make it faster? Modulo is slower than multiply, right? Modulo and division operation is slow, and multiply is faster. Plus and minus is faster, and or XOR is even faster. Actually, there is a parity reduction. Maybe you can find by yourself how to make modulo faster. All right. Or maybe we can discuss in the next meeting, or sometimes. Maybe it can pass the time limit if you use 2 log square solution. Anyway, there is another faster solution. The solution is just do this. Let's say R is the maximum k. R is log n, like this. Okay. And wait. I think okay. In the previous solution, we just need this value, right? But this value need this value, and this value need this value. Is it correct? Wait, sorry. Uh, I mean this value need this value. How do you think? I think not. If we are optimizing the memory, it means we want to find this, find this, find this, find this, find this, find this n log n, right? And then just ignore this, find this, find this, find this, find this, find this. This another n log n. And then reuse this. Is it correct? So it is still log square, right? Okay. All right. So actually, we can ignore this. The n log n solution is just ignoring this. So we are only finding this, right? So it means for the length of 2 to the j, the pace is always f0. The pace is f0. This is f1, f2, f3, and so on. Okay. Then how about the ORI? ORI ij, the pace is not always only p, but let's change the pace of ORI become f r minus j. Is it understood? Okay. How to do that? I think this is easy. You can easily find it. So for one value, you can solve it in n log n as well. So for just one value, okay, then of course the value is only ai. For two value, the base is f, for example, f19. Okay, so it means this plus this to the f19. But for 4, the base will be f18. Any idea for this? Okay, sorry. It is a prayer time in my city, so I think okay, you can try to find the idea for this by yourself. Okay, and let's continue our meeting in after break, inshallah. Okay, thank you very much. Assalamualaikum. Okay, let's start. Let's continue. Assalamualaikum warahmatullahi wabarakatuh. Okay, are you ready to continue? Okay, so do you have an idea to find the original hash in O n log n? Have you? So now for REIJ, it is the hash of original array starting from I. The size is 2 to the j minus 1. Sorry, 2 to the j only, of course. But the base is not b, but f r minus j. I mean, it is b to the 2 to the r minus j. Is it understood? Do you know how to find this? In O1, of course. So the total complexity become n log n. Okay, yes. How to use it?
Sir, my idea is to make a prefixum for each f of k and then just use the prefixum to compute ori of ij.
Okay, that's a good idea. Actually, my idea is using sliding window without prefixum. But maybe both of them are correct. Okay, so there is a question from CJ. What if we use original value with base p and then just multiply with f? No, not like that. So if we use that, it means it is became I mean this is multiplied by 1 and then multiplied by f. Wait, sorry. This is multiplied by f. This is multiplied by f times p. It is times p square, f times p to the 3 and so on. But what we need is this is f to the 0, f to the 1, f to the 2, f to the 3. Are they different? Different or same? How do you think? Different, right? So we cannot do that. So we can use prefixum or sliding window for each level. So you know, for each level, the base are constant. So for we want to find it level by level. When we find this level, we don't need the other level, right? Okay, just like Saram's solution. So actually it is hard to use perfect sum since if we use perfect sum means we create perfect sum in this way. Between the 0, between the 1, between the 2, and so on. Then how to get this perfect sum? So we divide them by between the p square. Okay, maybe you can still do that by some number theory idea. But my idea was like this. I just pre-compute this we got the value of this. Yes, sliding window is simple. So when we want to find this, we can just multiply this by p. So it means it is become p1, p2, p3, p4. And then added by this. This is become p0, right? And then reduced by this times p to the 5. Sorry, p to the 4. Is it understood? How do you think? Okay. So for each level, it is ON, and there are log n levels. So the complexity is n log n to find the ORI as well as to find the first table for the final reorder. All right. So that is the solution, the full solution. Is there any question about the solution? Or do you have another insight? All right. Okay. And I think sometime we need to discuss about period reduction, how to optimize the modulo operation. But maybe not now. Okay. Then let's continue to which problem. I think the first problem. So it is a encoder decoder problem, right? Yes, when we find the context about when we find the context that using functional type, so we will see some encoder decoder problems and also interactive problem. So let's see. I think some of you got which point? Ahmed got 28 and the other is 28. All right, yes, all of you got 28. Okay. It means you solve it. So solve this. I think the solution that using n log n bits, right? So how was your solution? Maybe your solution are same. So let me ask Ahmed, what was your solution for n log n bits? Okay, yes. Yes. To solve this, we need n log n bits, right? Because we want to make this value is equal to 1. So this is equal to 0. Okay. It means it is I think +1 is for sailing them. Alright. But for this, how many bits we need? Yes. 2n, right? And for this, it is easy. Just compress them, right? Just compress them, so the value is between 0 and n minus 1. So if we record them into log n bits, then we just need n log n. Then do you have any idea for the full solution? The hint is the material is always appear in two last contests. In this contest as well as this contest. Always in the first problem as well. So how do you think? Which topic? Solution for this, as well as this one. Okay. Segmentary like? No, not segmentary like structure. So what was my solution for this problem and this problem? My unique Q solution. That's it, TNC. Right? Or Cartesian tree. Okay. So now do you have any idea how to solve this using Cartesian tree? What if from the array we create Cartesian tree? Wait, we want to find the maximum, right? So what is the root if we have an array? The root is the maximum, right? And the right child is the maximum of this. Left child is the maximum of this. And so on. We have a tree or something like that. Okay. All right. If we have a Cartesian tree, okay, before that, okay, if we have a Cartesian tree, just ignoring the array, actually, we don't know whether this one is above this one and this one, which one is greater, we don't know, but we don't care, right? Because they always less than this. So if this is included, this is included, this is also included, so I don't care about them, right? So when we want to find the maximum between this and this, just find the LCA between this and this. The LCA is this. Is it correct? Okay. Or actually, after knowing this, we can generate the array. Let's make it n. This is n minus 1, n minus 1, n minus 2, n minus 2, n minus 2. And then we can just solve it using segmentary or parse table after generating this array, right? But we can use LCA as well. Why it always become LCA between this and this? Because the LCA is always between this and this. The LCA never here, right? If both of them are less than this, then the LCA should be in the other node, right? Not this. The LCA should be the root for the subtree, right? So it means the LCA always here. And the LCA always the maximum. Because if there is another value greater than that, then the LCA should be this. Because it is between this and this. So it never become like this because this one less than this. So it should be splitted into two different subtree, right? So that's why we can easily find the LCA of L and R. Even sometimes the parent is outside, but the LCA always inside. Okay. Then okay, now we know the decoder function, but how to encode this? How to store this into 2n bits? Any idea? Why 2? 2 means one for left, one for right. Yes, 2 childrens. So 0 means doesn't have left child. 1 means have left child. Okay. How about like this? For example, for this only has right child, of course. Actually, we can make it 2n minus 2 since, of course, the first value never has left child and the last value never has right child. But never mind, 2n is enough for solving this problem. Okay. And then what else? What if we know that this node has right child, this node has only right child, this node has both, and so on. This node is a leaf, so neither left nor right. Can we generate the tree only storing this? Any idea? You know, we do not store the root, right? We do not store the root, and we do not store which one is the left child, but only storing is it has any left child. Okay, how to know the order of the indices? We only has this array. It has right child. It has right child only. It is a leaf. It has both. It has right child only. It is has left child only. It is the leaf. It has both. It has it is leaf. It has both. It has right child only. It is the leaf. It is left. It is both. Only knowing this array, how to know where is the root? How to know where is the... We don't know the order, right? Okay. Any idea? Can you explain how to reconstruct the Cartesian tree? Just knowing this information. Okay, maybe TJ can explain. All right. Okay. How about the others? Okay. The idea is like this. We can start from the leaf. Okay. Let's activate this node, right? Okay. And then for the node, for example, this is only R. And now the right value is activate. So it means now we can activate this, right? How do you think? We can activate this after activating this. But we still cannot do this because the left of this is not it's not connected yet. Okay, how do you think? For this L, the left child is already exist. So we can do this. And then for this, okay, now the right one is already activate. We can connect this and we can connect this since you know this is already activate. We can connect this. After that, we can connect this as well. We can connect this. We can activate this and so on. And finally, we can activate this. So it means this is the last node, last activated node. So it is the root. Okay. Is there any question? Okay. So when we can connect the child, what if this is activated but this is not yet? So so wait. Is there any flaw here? This one. What if this is the left child? Is it correct? Wait, what if the tree is like this? Is the information same? It's only right. This left and right. This is left and right. Wait. Sorry, I think uh, the information stored in the pit is not like this, but we store this in the Euler tour order. This is LR, LR, R, R, none, and then LR. Yes, sorry. The order is not from left to the right, but in DFS order. All right. Is it understood? Okay, yes. So we can easily generate the tree. Okay, we still don't know where is it, but okay, it has left and right. Okay, let's continue to the left. And then for this, it has left only, for example. Okay, goes to the left. This has right only. Okay. This is don't have any child. Okay, then go back to this. Okay, right is done. Left is done. So go here. Right is not yet. Go to the right. LR, for example, go to the left. It is a leaf. Then it is done. Okay, we haven't tried the right. Go to the right. And so on. Is it understood? Then go to the left. This is leaf. Go back. Okay, there is no right child. Go back. We have tried the right. We go back. We have tried the right. It is done. All right. All right. So the order is based on the DFS order, not the order on the. So how to know the index? Okay, we can easily do this. The index of this is the size of this, right? The size of this plus 1. And also the index of this, the size of this plus 1. And so on. So now it is just like in order. Okay, so in the order we store is pre-order. But the index of our this is the in order, right? So we solve this order and then let's continue. Let's make it is equal to CND. And then for DFS here, this in the next CND, right? Okay. Is it understood? It is understood. And we can easily find the height or the depth. And we can find the LCA. All right. Okay. Is there any other flaw or is there any question? Okay, then please help solve this problem. Okay, so actually we don't know the index. We only know that the root has left and right child. Okay, or we still don't know the index, but we can make it number 1, right? That number is different with the index of the array, right? Okay, so let's differentiate between the index of the node and the index in the array. All right. The real value that we want to return is the index of the array, right? But how about the index of the node? The index of the node is the DFS order. I mean, yes, Euler tour order, right? I mean pre-order. Based on the pre-order, it means the root is not 1, and the left child is not 2, is not 3, not 4, not 5, not 6, and so on. Okay. But again, this is index for the node, index in the graph, not in the array. All right. So based on the information we have, we can easily construct the graph, right? LR means the left child of 1 is 2, right? For example, this is LR as well. The left child of 2 is 3. And then the right child of 3 is 4, and so on. We can generate the tree. Yes, unlabeled. We have known the tree. We have known the node of the index, but we haven't known the index of the array. Then how to know the index of the array? Just do DFS, but now it is not pre-order but in order. Do you know what is in order? What is the difference between pre-order, in-order, and post-order? In-order is, wait, sorry. Pre-order is doing like this. The index for the current node is equal to CNT plus plus, and then DFS to the left and DFS to the right. It is pre-order. How about the in-order? In-order is moving this line to this. This is in-order. But if we move here, it is post-order. For this, it is pre-order. Is it understood? Okay. So it means the first node we add a label is this. And then this. And then this. And then this. Then this. And then this. Finally, we know the order in the array. Okay, how do you think? Yes. Yes, we can use sub-tree size. But if you use this, we don't need sub-tree size. Okay, yes, sub-tree size is different. I think maybe for pass order. For pass order, it is equal to sub-tree size, right? But for this problem, we need we need in order, not the post order, right? Okay. If you find the in order using size, I think like this. The order of this, after order of the current, is equal to the order of the parent plus the size of the left child plus 1. I think it is more complicated. I think this one is easier, right? Because we need order of the parent as well. Order of the parent plus size. Okay, so I think using this idea is easier. Okay. Now we know for each node what is the value inside this, and for each value we know the index of the node, right? So for every input of LR, we can easily find the node for L and find the node for R and find the LCA of it. And then finally, we want to know the index of the array in that node, in the node of LCA. Okay. Is it understood? All right. So you can get these 72 points. Okay. Is there any other question? There is no, so there is one problem left. So we have 3 consecutive contests that the first problem using Cartesian tree, right? I hope there will be no no Cartesian tree in the next contest. All right. No, I think all Cartesian tree problem already solved. All right. So this is the last problem, but I don't know. Uh, this is become the easiest for you. All right. Yes, you can try all idea or algorithm that can be used for a problem. Okay, Ahmed got accepted. Maybe after contest, Soram got accepted as well. And GJ, how about Anik? Okay, Anik got 18, I think. All right. So you have known the idea, but you got a bug, didn't you? All right. Okay. Yes. So how? So what is the complexity for your solution? N log n or O(n)? N log n. All right. So maybe in the test case is big. Okay. No, I think yes. If you implement it correctly, N log n pass the time limit. The time limit is only 0.6 millisecond. Okay. 2.5 E6 times 21, for example. So it is around 32, maybe 32 no, not 32, maybe 50. Yes. All right. Maybe if you implement it clearly, it can pass. So how was your solution? So TJ got accepted in the first time. So can you explain your solution?
Sir, first I made the DP formula that DPI is equal to minimum of DPJ plus maximum of J plus 1 to I, and we want this overall J which are greater than equal to I minus K.
Okay.
So to optimize this, we can think about using the monotonic stack and keep the AIs in decreasing order. And we know that DP is increasing, so we can say that for each one of these maximums in the stack, the minimum value of the DP uh, will be like DP of previous value in the stack and the current maximum. So we can keep a set and store all of these values in the set, and as we change the stack we can update the set as well. This way we can, and when we want to get the DP value we can just get the minimum in the set. That will be our answer.
Okay. Yes. And J salt not less than I minus what? Minus K. Is it correct? Yes. Alright. Okay. Yes, so it means if we use set, then the complexity become n log n, right? Because we need to remove the chain that is less than I minus K, right? And we want to find the maximum among these. So do you know TQ optimization, monotonic TQ? Yes. Can we use monotonic TQ for this problem? So we are storing the index and the j and the value. And it is sorted. J is always increasing. And this is also increasing. So if we have a new value that is less than this, just pop this, pop this. So it is still increasing, right? And now we can make sure that the minimum one is in the front. But if j is less than k, just pop them. So we need to pop from both sides. So that's why we need KQ instead of stack or queue. Okay. Is it understood? So the complexity become O1 for the transition, right? O1 amortized.
Sir, will the first element of deck will be increasing in dp of I plus a as well?
So it is, for example, this is J. This is GP of J plus this, right?
Yes. So what, like I tried this, but I think there was a bug in this, that if we have, like we have maintained this uh, deck, and as we add a new element, we might remove, let's say if we remove all of the previous elements in the deck because the current one is giving us better answer. So, and a little later something appears uh, which is less than this, so we will be actually greater than this. So if and then we have to remove this one from the deck, so because we have to keep the j's sorted as well. But as we remove this from the deck, we can now add the previous values which we deleted back again, and they might give us better answers.
Okay, yes. Yes, I was already uh, concerned about that case. I already realized. Then when there is a new value here, okay, if the new value is like this, so it won't change the others, right? But what if the new value is greater? Then of course we need to pop this. Okay, just remove them. And the only value changing is only this. For this it is not changing, for this it is not changing, right? Okay. So we also pop this as well. Then we are not only adding this value, but we only adding the new value of this. Regardless this one is already popped before or not, but we want to add a new value because it might be better, right? Just like what you say, this might be better. That's why we also need to push this as well. But for the others, it is not changing. Okay. So we don't care about this one is already popped or still inside the deck, but we want to push the new value of this. Okay, how do you think? Is it solving the problem?
Maybe not, sir. Like,
Okay.
yes, for now, I think it will give the correct answer. But after that iteration, it if we delete the previous one, like the I minus 1,
Yes.
and then the deleted ones in the previous iteration might become alive again.
When we delete from front or from back?
From back.
From back. Wait. If it is from back, so it means I see. Sometimes the value is increased. But don't worry, I think. Okay, for example, this node is not in the set because this one is better. All right. This is better. This is better, and we remove this. It is not in the set or in the tag. But it is in the set, right? It is in the set, but not in the tag. And then when we add this, we remove this, we remove this. This is not in the tag, but in the set. We remove this, remove this. This is initially isn't in the tag, but after changing the value of this, we will push it to the tag, right? Okay, and it will never wait. Since we already delete this, so now the value from this, the next value is this. I mean the previous value. So I think we already remove this, so it is okay. I think it is still correct. So in the set, it is still complete, but in the tag, sometimes some maximum is removed. All right. Is it understood? Or is there any other concern? All right. So it is prayer time again in my city. So I think that's all for our discussion again for today. And let's close our meeting with praying. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum